Hello, and welcome to this week's segment of What's the Sitch? Today, not only am I going to talk to you about Faraday's Law, I'm going to prove this theory in practice with my very own DIY Faraday Flashlight. So, to get right into it, this flashlight works on the simple principle of Faraday's discovery, which states that any change in the magnetic flux within the vicinity of a conducive material, such as copper wire, induces an electromotive force, thus producing a current within said conductor. So, in this case, the magnet moves when you shake the flashlight, and thus causes a change in magnetic field. The coil of wire that's wrapped around the outside of the tube and the moving magnet induce a field. Now, induction itself is an observed phenomenon, therefore it's hard to explain why a changing magnetic flux induces current. However, it stands to reason that if a flow of electrons or electric current can produce a magnetic field, then a changing magnetic field should be able to induce a flow of electrons or a current. And now I'm going to prove to you how Faraday's discovery put into practice does indeed work. Stay tuned! As you can see, my flashlight does indeed work. However, in my case, the current my flashlight induces is just enough to power the LED bulb. For future reference, there is a multiple number of ways to increase the current that's induced within your flashlight. The first alternative being increasing the number of turns of copper wire on your flashlight. This is because the number of turns is directly related to the voltage generated. In a perfect uniform magnetic field, doubling the number of turns would therefore double the voltage generated. You could also use a stronger magnet or find a way to increase the speed at which you shake the magnet. For this solution, using a crank flashlight would be the best alternative. You could also incorporate a capacitor into your design, which is a storage device that smooths out your current and provides a steady flow of electricity instead of the short bursts that cause the LED to blink on and off. Despite the adjustments that can be made to my flashlight, it's pretty obvious to see how important and invaluable Faraday's discovery is in practical applications in today's society. That being said, one of the most important applications of this idea can be found within generators and motors. A generator converts mechanical energy into electrical energy, while a motor converts electrical energy into mechanical energy. Also, to be able to produce current using induction on a large enough scale to power houses and other industrial buildings would certainly be significant, as we could eradicate the use of other energy sources, such as natural gas or solar energy, that are either harmful to the environment, expensive, or inefficient. And that concludes this week's segment of What's the Sitch? With me, Sam. Hey Sitch, why does a physics textbook always look unhappy? Because it has a lot of problems.